All right, welcome to Lab 5. This one is about rational numbers and functions, of course, because we just learned about those. So we are going to make our own little rational number library, and you might be wondering, what in the world is a rational number? If you've never heard that term before, it just means fraction. It's any number that looks like a over b, so it's just a fancy word for fraction. And we're going to work with these. We're going to do math with rational numbers, okay? And that's going to involve simplifying them, because remember that you can always simplify some fractions. And then also, I think we'll have a multiplication function as well. So let's talk about all of that and get into it. So here is the code that I will be giving you, all these files. We have a header file now, woohoo, and here is what I want you to do. So we're going to make a rational number library. You're going to be implementing all the functions in rationals.h inside of rationals.cpp. So let's look at the .h file first. Here it is. Here are the fancy functions that we'll be working on in the library. So I give more comments in the CPP file, which we will look at next, but here are 3 functions. And every rational number has a numerator, right? The thing above the line and a thing below the line, the numerator and the denominator. Yes? So that is how we are going to be giving fractions to functions. If we want to simplify a fraction, we're going to give the numerator and the denominator separately. Okay? Things like that. If we want to print or convert into a string a rational number, we're going to give its numerator and its denominator separately. If we want to multiply 2 rational numbers, we give the numerator and the denominator of the first one, the numerator and the denominator of the second one, and we have to output a rational number. The way that we can do that and return 2 things at once is with references, right? We can pass along references to the result numerator and the result denominator, and we'll set those based on this multiplication of these 2 rational numbers. Cool, huh? So that's rationals.h, and so you're going to implement those functions in rationals.cpp, okay? And let's go and talk about those, and then we'll get into like what's going to happen when you run it. So here's rationals.cpp. I have given you a helper function called GCD, right? We've talked about this before. It calculates the greatest common divisor of 2 numbers, and that's going to be helpful when you simplify your fractions, your rational numbers. You use the GCD to help simplify your fractions. So let me talk to you about that, and then we'll get into other things. So here, I'll just keep on writing on our slides from the lecture. So here's the stuff for your lab. When you simplify a fraction, remember, like if you have 2 over 4 or something, that's not simplified yet. It should be 1/2 to be fully simplified. How do you notice that you want to divide by 2 to make 1/2? You need to divide by 2 and divide by 2. How do you notice that it's the 2 that you need to divide by? That's where the GCD comes into play. If you take the greatest common divisor of the numerator and the denominator of any fraction, that will give you back the number to divide by. The GCD of 2 and 4, the greatest common thing that goes into both, is 2. And that is how you will simplify your fractions. Just take that GCD and divide the numerator and the denominator by it. And that will simplify your fraction to smallest terms. Isn't that cool? So make use of that. GCD already gave it to you. And then you will work on these functions. Okay? So the first is simplification. This is what you're going to do. You'll use GCD, but you have to watch out if the rational number was negative, okay? Because when we simplify our rational numbers, we want to end up with only the numerator being negative, okay? Because it's not fully simplified if we have a rational number that looks like this, like 1 over -2. No, it should be -1 over 2. That's the fully simplified normal form of a fraction, right? The negation goes on the top. So essentially, rational simplify is you dividing by the GCD after worrying about negation, about negatives, okay? So you have to worry about whether or not the rational number is negative or positive by checking the cases. So the negative sign might be both places, might be on the top or the bottom right now. You have to figure out which case you're in. So check all of those. And then you have to save that information for later. Because when you call GCD, sadly, you can only give positive numbers. GCD does not work when these numbers are negative. So you have to remove the negativity from your numerator and your denominator for a split second. You have to remember that it was supposed to be negative, because you can't use GCD otherwise. I hope that makes sense. Yell at me if it does not. And then you can use the GCD finally, simplify your fraction, and then multiply your numerator by 1, negate it, if you realize that, oh, I had a negative fraction. Because you have to get rid of that negativity for a second so that you can use GCD. Okay? And that is simplification. You're going to set these variables. You're technically not returning anything. You're just changing what was passed to you because it was passed by reference. Isn't that cool? So that's simplification. The other main function that you'll be working on is rational times. So you're getting two fractions, this one and this one, and you're multiplying them together, putting them in the result. Okay? So you'll just implement that. Remember that if you're doing A over B times C over D, the result is AC over BD, right? That's how you multiply fractions. And so that's your result. That's what you'll put in result numer and result denom. But I also want you to simplify before you finish this function. So make sure to simplify after you do that multiplication, because most likely you'll have some things that can cancel out from here. Okay, so that's rational times. And then the final function that you'll be implementing is called rational pretty string. It just converts a fraction to a pretty form of a string. So if the fraction was 2 over negative 44, you would simplify it, make it negative 1 over 22, and then print it with a nice, or make a string, of course. You're not printing anything. Sorry. You're going to make a string with the numerator, a space, a slash, another space, and then the denominator. Okay? So that's what you'll do. You will make a big, nice string that is pretty. It's the pretty form of the fraction. Okay? That's all. And in order to build up this string, you're going to have to put numbers inside of it, which means you're going to have to convert numbers to strings. You can use the toString function to do that, okay? Use the toString function in the string library to convert an int to a string so you can add it into the string that you're trying to build up, okay? So that's the library that you'll be implementing. That's the rationals library. And that is the main bit of your lab. I've given you a sample program that you're not going to be filling in. It's a program that uses your library. It's called Sampleprogram.cpp. It just imports your library and lets you type in some fractions so that you can test all the things that you're printing. And so if you run it with these inputs, for example, this is the output that you should get. That's what it should look like. So that's your program there. And then finally, I have made a test file, test.cpp. I've made some tests for you already. Here they are. They test in more detail your functions that you're implementing in this library. So get those passing first. You'll compile and run that. And then I want you to write your own tests. So this is why it's going to be a 2-week lab. This is going to be due week 10 because you're also writing some of your own tests. I want you to write 2 more tests in the same style as the ones that I've given you here. Okay? So you can use some of these as inspiration. Add 2 more tests. So you're going to end up calling assert true 2 more times. I want to see 2 more passed lines output when this is getting auto-graded. Okay? So write 2 more tests in the same style and get them to pass, and that is your complete lab. Okay? That's why it's a 2-week lab. So you're going to implement your rationals library in rationals.cpp. So that's what you'll be turning in there. And then you're also going to add some tests to test.cpp. So you'll also turn in that file. These are the only 2 files that you should modify. You should not change the .h file. You can change sample program all you want, you just won't turn it in. That's just for you, okay? So don't change the header file. That is got to stay how it is, okay? So I think that's everything that I wanted to talk about. That is your lab 5, and you get to practice all the stuff that we've been learning. So ask me if you have any questions, and I will see you next week.